Hi, it's Mr. Benson here with a late night video on congruence and similarity. So it's the second one for this unit, and it's just quickly going over congruent and similar figures. Now obviously some of you have probably worked through some of this already, but feel free to watch this again. But certainly if you're only starting on chapter 5 this week, then this would be the second one to watch. So congruent and similar figures, what do we mean by this? Figures are congruent if they are identical in size and shape, so all the corresponding sides and corresponding angles are equal. Now they don't always look the same because they can be rotated or reflected, so they can look quite different. So I've got my pentagons here, they're all the same. I've rotated the one in the middle, and the one on the right hand side is just flipped vertically, but they're all the same shape, so exactly the same size and shape, which is what we mean by congruent. Okay, now congruent triangles is a good place to start, because if you think back to trigonometry, if we know something about a triangle, so if we know its angles, or some of the angles and some of the side lengths, then we can use trig and also Pythagoras to calculate everything else. So we don't need to know everything about a triangle to know that it's congruent. But like all congruent shapes, congruent triangles have exactly the same size and shape, and we're going to look at some simple ways of confirming that they are congruent. Okay, the first simple way to determine that triangles are congruent is what we call side, 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 and it's just when all the corresponding sides of a triangle are equal. And if all the corresponding sides are equal, all the corresponding angles must be equal as well, so the triangles are identical. The next one is side, angle, side. Two corresponding sides and one corresponding angle. Again, through trigonometry, we could calculate everything else and show that the triangles were completely the same. Angle, side, angle. Two corresponding angles and one corresponding side. Also allows to confirm that they're congruent. Now, another one that you will be expected to know is called right angle hypotenuse side. Now this is for right angle triangles only, and it's really just a special case of side, angle, side. So you know two sides and a corresponding angle. It just happens that in this case they are that it's a right angle triangle. And moving on, let's have a quick look at an example. So if we've got two triangles here, now they look slightly different, but it's only because of rotation. But when you think about what we know about the two triangles, you can see that we know, so this side here is 10 centimeters. Now this side here is 10 centimeters. Now that doesn't necessarily mean they're congruent at this point, because we've got to make sure that everything is corresponding. Now when we look down here, the base is 8 centimeters. Now the base of this one's also 8 centimeters, so that's promising. So these two seem to be corresponding with each other. Now the angle here, 60 degrees, now that's opposite the 10 centimeter side. Over here, again, it's opposite the 10 centimeter side and adjacent to the 8 centimeter side, so everything seems to be corresponding. If we were going to label these, we could maybe label this as side 1 corresponding with that one, and this as side 2 corresponding with that one. But the important thing here is we've identified that we've got two corresponding sides and one corresponding angle, and so we would say that this is congruent, and the reason for it being congruent is side, angle, side.